Hello everyone, this is the 9th session of Unit 1, Heat Power Engineering. In this session, we discuss about some simple solved problems. Take first question, that is during the compression stroke of a heat engine, the work input is 100 kilojoules per kg. Heat rejected to the cooling water is 50 kilojoules per kg. Calculate the change in internal energy of the working fluid and state whether it is gain or loss. First, we read the question carefully and understand the given data and what is find out what value is unknown that can be find out. Take given data. Work done W is equal to minus 100 kilojoules per kg. So here work done on the system, that means work is entering into the system. So the sign taken as negative and heat added, that is equal to minus 50 kilojoules per kg. Here also the heat is rejected, so minus is taken. Next solution. According to first law of thermodynamics, Q is equal to delta E plus W. Q is the heat supplied. Sum of delta E is internal energy and W is work done. Here Q is minus 50 as in given data is equal to delta E plus or minus 100. Therefore delta E is 50 kilojoules. Here delta E is taken to left side and this 50 is taken to right side. So this is 100 minus 50. So the change in internal energy is equal to 50 kilojoules. Therefore, change in internal energy is positive. So energy is gained by the system. Next question. A closed system undergoes a process change in which 2 kilojoules of heat energy is supplied to the system. Find the change in internal energy under the following conditions. In first case, 0.5 kilojoules of work is done on the system. Second case, 0.75 kilojoules of work is done by the system. Here there are two cases. Here we find out one by one. Here given data, that is heat supplied Q is equal to 2 kilojoules. So solution. In case 1, work done on the system W is equal to 0.5 kilojoules. According to first law of thermodynamics, we know that Q is equal to delta E plus W. Here Q is 2 and delta E is unknown and work done W is minus 0.5. Therefore delta E is equal to 2.5 kilojoules. In second case, work done by the system is W is equal to 0.75 kilojoules according to first law of thermodynamics. Q is equal to delta E plus W. So Q is 2 that is equal to change in internal energy is unknown plus 0.75. Here the heat, here work is positive because work done by the system. Therefore delta E, change in internal energy, is equal to 1.25 kilojoules because delta E taken left side and 2 is taken to right side. So 2 minus 0.275 is equal to 1.25 kilojoules. It is the change in internal energy. Next, problem 3. The pressure of a steam inside a boiler as measured by pressure gauge is 1 Newton per millimeter square. The barometric pressure of the atmosphere is 765 millimeter of mercury. Find the absolute pressure of steam in Newton per meter square, kilopascal, bar and Newton per millimeter square. Take given data. Gauge pressure is equal to 1 Newton per millimeter square. Atmospheric pressure is equal to 765 millimeter of mercury. Solution. We know that atmospheric pressure is equal to 765 millimeter of Hg. That is equal to 765 into 133.33 Newton per millimeter square. Since 1 millimeter of Hg is equal to 133.33 Newton per millimeter square and 1 atmospheric pressure is equal to 760 millimeter of Hg. 1 atmospheric pressure is equal to 1.01325 to the power of 5 Newton per millimeter square. So this 765 multiplied by 133.33 Newton per millimeter square. So this is equal to 0.102 into 10 to the power of 6 Newton per millimeter square. So this is the answer in Newton per millimeter square. Absolute pressure of steam is equal to 1 atmospheric pressure plus gauge pressure. 0.102 into 10 to the power of 6 plus 1 into 10 to the power of 6 Newton per meter square. So that is equal to 1.102 into 10 to the power of 6 Newton per meter square. Add these two values. The 10 to the power of 6 is common, so it is 1.102 into 10 to the power of 6 Newton per meter square. That is equal to 1102 kilopascal, because 1 kilopascal is equal to the power of 3 Newton meter square, and that is equal to 11.02 bar, because 1 bar is equal to 10 to the power 5 Newton per millimeter square, and that is equal to 1.102 Newton per millimeter square, because 1 millimeter square is equal to 1 into 10 to the power 6 Newton meter square. Problem 4. In condenser, condenser of a steam power plant, the vacuum is recorded as 700 millimeter of mercury. If the barometer reading is 760 millimeter of mercury, find the absolute pressure in the condenser in Newton per meter square, kilopascal, bar, and Newton per millimeter square. First we take given data. Vacuum pressure is equal to 700 millimeter of mercury. Barometer reading is equal to 760 millimeter of mercury. Here also 1 Newton per millimeter square is equal to 1 into 10 to the power 6 Newton per meter square. 1 kilopascal is equal to 10 to the 3 Newton per meter square, and 1 bar is equal to 10 to the 5 Newton per millimeter square. Solution. Absolute pressure in the condenser is equal to atmospheric pressure minus vacuum pressure, that is equal to 760 minus 700, that is equal to 60 millimeter of Hg. So 1 millimeter of Hg is equal to 133.33 Newton per meter square. Therefore, it is multiplied to 60. That is equal to 7999.8 Newton per meter square. So that is equal to 7.9998 kilopascal, because because 1 kilopascal is equal to 1 into 10 to the power 3 Newton per meter square. That is equal to 0.07998 bar, and that is equal to 0.00799998 Newton per millimeter square. So it is completed. Simple problems. You can solve the another problems in books. Thank you.